We're basically continuing our discussion, what we were doing with functions in the last section. But here we'll be focusing more on quadratic functions, and then we'll actually build up to higher degree polynomials. Okay, so let's take a look at this. So we're starting out with our quadratic function. Now we looked at these as quadratic equations, earlier in chapter 2, and of course in chapter 1 also. So here, of course, when we're talking about a quadratic function, we're basically saying it's a quadratic or a second degree polynomial. So that means the highest exponent you should see on your x variable should be the degree 2, right? Exponent of 2. So the general form of your quadratic function is actually going to look like this. F of x equals ax squared plus bx plus c. And of course, we put a restriction by saying that a cannot equal 0. Because if a becomes 0, then 0 times x squared will become 0, and you will lose the quadratic form of your function. So to keep that, we put the restriction that a cannot be 0. Now, in section 2.2, we also looked at the quadratic function in the transformation form. So that was your f of x equals a times the quantity x minus h squared plus k. So this is what I call as the transformation form. So basically what we are going to be doing as the first part here is kind of talking about how we can go back and forth between the two forms. So they are saying it's easy to convert from our transformation form into the standard. Hold on, guys. Okay, so as I was saying, it's easy to convert from the transformation to the standard form. What you do is you start by squaring that x minus h quantity squared. So you would do a FOIL on that. We would then distribute the value of a, and then of course bring the k into our calculation. So going from the transformation form to the standard form is actually very simple and straightforward. But when you have to go the other way around, so if I want to go from the standard form into the transformation form, we will be needing to use completing the square. Now remember, we talked about completing the square in chapter 1. We talked about completing the square in chapter 2. So we're bringing back that same concept here now by converting it from the standard form into the transformation form for our quadratic function over here. Now they are saying when we are completing the square, add the last or the constant term to the perfect square trinomial to both sides of the equation. And we have seen that, when we were doing equations of circle in chapter 1, this is exactly what we did. We, took the perfect square trinomial by adding, this constant term to both sides of our equation. Now, we will not be able to do that in this case, because normally when you are completing the square, and let's say you have, I don't know, something like x squared plus 4x plus 5 equals, I don't know, 7. If you had an equation of this form, then we would take our first term and the middle term, and we would try to make that into a perfect square trinomial. So remember, for perfect square trinomials, we use completing the square, and completing the square would be where we take this middle coefficient of 4 divided by 2, and we square the entire thing, which then ends up giving us, of course, 4 divided by 2 is 2. 2 squared gives you 4. So the idea is we would take this number 4 and we would add it to both sides of our equation. And, of course, we add it to both sides of our equation because we want to maintain that balance. So whatever you do to the left-hand side, we do to the right-hand side. Another step that we would have actually taken is we would have taken this number 5 and moved it to the other side, because he's not really solving any purpose on this side. And you would end up getting x squared plus 4x, and then this number 4 that we added. And then, of course, clean up the right-hand side, which would end up giving you 6. Now, this left-hand side, is what we call as the perfect square trinomial, because when you factor this, it will factor into x plus 2 and x plus 2, or basically x plus 2 squared. So that's usually the idea behind using completing the square. We are trying to create a perfect square trinomial, so that it's easily factored. Now, what we are basically saying here in the quadratic function calculation, we will not be able to do this on both sides of our equation, because on one side, we will keep that f of x. So wherever you see the y or the f of x on the left-hand side, that part cannot be changed. All the calculations that you will be doing, you are going to be doing on the right-hand side. Okay, let's see, Deborah just came in. Okay, so let's go ahead and take a look at how we will need to do these calculations by keeping all our calculations on one side. So they're basically saying we will need to add and subtract whatever terms we are working with on the right-hand side. The other thing we have to be careful about when we are working through completing the square is that the coefficient of your x squared term always has to be 1. So there is obviously a possibility that your coefficient may not be 1. And so again, this will be something that we will need to consider when we are trying to work through these calculations of completing the square. So let's go ahead and take a look at this example over here. They're asking us to write the quadratic function in the form of y equals a times x minus 8 squared plus k. Remember, this is what I'm calling as our transformation form. Because remember, this is what tells us how many units to move up and down, how many units to move right and left, if you're going to have a stretch or a shrink or a reflection. So that's why we call this the transformation form. So let's go ahead and take a look at this first example here. Okay, so we are given y equals 2x squared minus 12x plus 22. Okay, so the first thing we actually need to do is make that x squared have a coefficient of 1. And right now, of course, our coefficient is 2x squared, right? So we need to get rid of that 2. Now, normally, again, if we had an equation like this, we could have just divided everything by whatever the coefficient might have been. But again, we cannot do that in this case. So you know what we end up doing is we use factoring. Because remember what I said, the left-hand side has to stay a y. We cannot do any calculations on the left-hand side. So the first step we are going to be doing is just between the first two terms, that 22 at the end is going to stay as it is. From the first two terms, we are going to factor that 2 on the outside. So we're going to bring the 2 on the outside. You will be left with x squared over here minus what happens to the 12x term? What are we going to be left behind with over there? So when you factor out the 2, yeah, very good. You will be left with the 6x, right? Because 12 divided by 2 will give you the 6, and that 22 will stay as it is also. So now what we have done is we have created that x squared that has a coefficient of 1. And now what's inside the parentheses? That's the part we need to complete our square on. So we just need to complete the square on x squared minus 6x. So now our middle coefficient is this number 6. So you take the number 6 divided by 2, and then you square that. That's how completing the square works. So of course 6 divided by 2 will give us 3. 3 squared will of course give us 9. So that means to complete this inside term into a perfect square trinomial, we would need to add 9 to it. But you know, again, guys, what's happening is all our calculation is happening only on the right-hand side. We cannot, again, add 9 to both sides of our equation. So to maintain the balance of our equation, since I'm adding 9, at the same time, I am also going to subtract 9. So that way I'm basically adding the 9 and I'm subtracting 9 and it's supposed to cancel it out. So it won't change the value of my equation. I will still be able to keep the value as it is. And then of course, bring that plus 22 down at the end. Now we don't want to cancel out the plus 9 or minus 9 because we brought that into our equation. We need it. For completing the square, I only need these three terms because they make our perfect square trinomial. So this minus 9 is the extra term inside the parentheses. So we need to bring it outside of our parentheses. To bring it outside of our parentheses, since I have this 2 in the front, we will need to multiply this 2 with the negative 9 and bring it outside of our parentheses. So that means we will be left behind with 2 in the front, x squared minus 6x plus 9, which is what I just want inside my parentheses. And then when I multiply 2 times negative 9, I get negative 18, and then bring down that plus 22. So this is how we actually get rid of that negative 9 and bring it outside of our parentheses. Does that part make sense, guys? Because I don't want to go forward if any of you are having trouble at this point. So any of this you would like me to go over before we move forward? Okay. Not seeing. Okay. All right. So now that we have brought the negative 9 outside by multiplying with the 2 in the front, we get negative 18. Now we can go ahead and factor the parentheses part. So we're basically looking for two numbers that multiply to give us 9 and add up to give us negative 6. So what do you think those two numbers will be? Yeah, very good, Audrey. So it's basically going to be a product of negative 3 and negative 3. So negative 3 times negative 3. Yeah, very good, Meredith, to the second power. Because, you know, these are perfect square trinomials, which means both our numbers have to be the exact same number. So it's going to be a product of negative 3 and negative 3, which gives us 9. And of course, negative 3 plus negative 3 will give you negative 6. So the parentheses factors into x minus 3 quantity squared. And then, of course, go ahead and combine the negative 18 with positive 22, which will, of course, end up giving us plus 4. And you will see this is our transformation form over here. So you've got your a x minus 8 squared plus k. So that's what we have done, is converted this from the standard form into our transformation form. And this is what they were asking us to do. So that's how this process basically works. Factor out that 2 in the front from the 2x squared minus 12x term. We're left with x squared minus 6x inside the parentheses. You take that middle term coefficient, which is the 6. 6 divided by 2 gives us 3. 3 squared gives us 9. And then inside the parentheses, we're adding and subtracting 9. We don't really need that minus 9 inside the parentheses, so we multiply that with the 2 in the front, bring it outside as negative 18, and then you're basically adding negative 18 with plus 22, which gives you the 4, and then factor out the parentheses part, x squared minus 6x plus 9, which factors into x minus 3, the whole quantity squared, and this is how we are converting it into the transformation form. Now, the other part they were asking us was to sketch its graph. Now remember, this is still transformation, so you can kind of think of that positive 4 at the end being our k value, which means our graph is moving 4 units up. The x minus 3 inside the parentheses, the 3 is the h value, and since it's x minus 3, that tells us 3 is a positive number, which means our graph is moving 3 units to the right. And of course, the positive 2 tells us we have a stretch of 2 units. So you can use transformations to help you graph this, or you can just create a table and help you graph this. But we know our graph has to move 3 units to the right, and it has to move 4 units up. So that's definitely got to be one of the points on our graph over here. So we can go ahead and do a table if you like. We can do on the original equation, or you can use the transformation. It really wouldn't matter. So maybe we'll do -1, 0, 1, 2, 3, 4, and 5, and let me see what kind of x values you come up with. Sorry, y values you come up with. And since we know our graph has moved 3 units to the right, that's why I'm not including too many negative numbers in there. But if you wanted to get an idea, you can definitely do more negatives. But since we know our graph is going to be more towards the right, that's why I went with more positive numbers. So what do we get for -1? Okay, Mackenzie, no problem. Thank you. Okay, Audrey, you got 20 for which number? Which x value? Okay, check your math again because I got a different answer for that. Yeah, that's what I had, 36, what Clinton had. Okay, for 0, what will we get? Yeah, very good, because 0 is actually pretty straightforward. 2x squared will become 0, 12x will become 0 when you plug in 0 for your x. So that means you will end up getting 22, which is going to be our y-intercept. What do we get for +1?
12.
12, very good. +2?
6.
6, okay, that should be a number we will be able to graph. Okay, let's see, +3.
And 4?
Yes, it should be, because obviously we saw that our graph moves 3 units to the right and 4 units up, so that was the point that I had already plotted. So 3, 4 as the ordered pair is correct. Okay, for +4? I've got 6 from Lori, and then was the 2 for number 5, which I don't think it would be positive. Yeah, it should be 12. Okay, very good. So let's see. Since we are looking at a 10 by 10 graph, we should be able to graph these 3 points, you've got 2, 6, and 4, 6. Okay, so it should look something like this. Now, I just wanted to show you what this would look like if we try and graph both the standard form and the transformation form. Let's go to our Desmos over here. So we've got 2x squared minus 12x plus 22. And you should be able to see that it crosses our y-axis at 0, 22, which is our y-intercept. The lowest point on our graph is right here at 3, 4, which is, again, you know, your graph was moving 3 units right and 4 units up. Now with the transformation form, we had 2 on the outside, x minus 3 squared, and I believe it was plus 4. Yeah. And you will notice that it overlaps right on top of the graph that we originally had. So as I was telling you before, you know, we're obviously not changing the graph. It's the same equation, it's only being rewritten, and this kind of proves that, you know, they are exactly the same graph since they overlap on top of each other. Now, what can you tell me about the domain and range for this function over here? Okay, Meredith, I just saw your message. Okay, no problem. So what can we say for the domain of this function?
Negative infinity to positive infinity.
Yeah, very good, Morgan. It will be all real numbers. Audrey, Meredith, very good. And again, you know, this is a parabola opening up. So obviously that means both the arms are going to go up, but they're also going to be headed left and right. So they'll be covering all the x values. Now, what can we say about the range for this function? The y values.
Including for infinity.
Very good. Yeah, because you can see on the y-axis, the lowest point is at number 4. So that's going to be the lowest point, and then your graph is, of course, headed up towards positive infinity. So including 4, going up to positive infinity. Alrighty, very good. All right, so the graphing, of course, we've done extensively in chapter 2, but the main part here I definitely want you guys to be comfortable with is converting it from the standard form to the transformation form. So again, if you have any questions, please let me know. But we'll go ahead and look at our next example here. So this one is giving us y equals 3x squared plus 4x plus 2. And, you know, I picked this example on purpose because, you know, in my MATLAB, since it auto-generates all the numbers, a lot of times you can end up with examples like this where, you know, the numbers don't factor out as easily as we saw in example 1, where the 2, you know, evenly factored out with the 2 and the 12. So in this case, what's going to happen is when we factor out that 3, you of course will be left with x squared over here, but you know 3 does not go into 4, so I'm not really able to factor out a 3 from that 4. So what we end up doing in this case is we just divide the 4 by 3, and the reason we do that is just imagine this over here. You've got 3x squared plus 4/3 x. If I take this 3 and multiply it back into my parentheses, the idea is we should go back to the original equation we came up with. So the 3x squared will of course multiply to give us 3x squared. And then when I multiply 3 times the 4/3 x, the 3 and the 3 cancel each other out, leaving us behind with that 4x. So you will see we will end up back at the original terms. So that's the reason why, since we cannot factor out the 3 from a 4, you just end up dividing it by 3. And then, of course, at the end, we want to make sure we have that plus 2. So this is kind of what we need to do in this example over here. Now, once you have that 3 on the outside, we have our x squared, which has a coefficient of 1, which is why we did this. So we have our two terms, x squared plus 4/3 x. Now we are ready to find our completing the square term. So that means we would be taking the term which is 4/3. Technically, we would need to divide this by 2. But since this is a fraction, instead of dividing by 2, you can also multiply by 1/2 and you still get the same result. So since my coefficient here is a fraction, 4/3, I'm going to multiply by 1/2, which will end up giving us 4/6. But you know, it's a fraction, so reduce it. And when you reduce it, you of course get 2/3, and then you square that. The other thing you could have done is 2 goes into itself once, 2 goes into 4 twice, and you could have reduced it into 2/3 at that stage also. So whatever you're comfortable with. But once you reduce your fraction, go ahead and square it. And of course, we will end up with 2 squared, which is 4, 3 squared, which is 9. So this is the term we will need to add and remember subtract from our parentheses. So x squared plus 4/3 x plus 4/9 minus 4/9, and then that plus 2 on the outside. Is everybody okay so far? So you saw how we brought out the 3. Since the 3 does not go evenly into 4, we ended up making it a fraction of 4/3. And then once we completed our square, we had to multiply our 4/3 by 1/2, reduce that fraction, which reduced down to 2/3, and then you square it, which gave us the 4/9. And then to maintain the balance of our equation, we add the 4/9 and subtract the 4/9. And then like you saw in the previous example, we only need to keep the first 3 terms inside our parentheses. So just like we did before, to remove that negative 4/9, we'll go ahead and multiply the 3 with the negative 4/9 and bring it outside of our parentheses. So we should be left behind with 3 and then inside the parentheses x squared plus 4/3 x plus 4/9. And then of course we'll need to bring 3 times negative 4/9. What will that give us? If it helps, you can write it as 3/1. So again, you can multiply and then reduce, or you can reduce it first. So 3 goes into itself once, 3 goes into 9 3 times. So you basically end up getting negative 4/3. So when we bring our 3 times negative 4/9 out, it becomes negative 4/3. And then you still have that plus 2 at the end. Now we need to talk about how we can factor this. So we've got x squared plus 4/3 x plus 4/9. If you remember, I had mentioned this the last time we had done completing the square. If you go back to this calculation that we did here for completing the square, you took 2/3 to the second power to get 4/9, right? So that means when you're factoring, you can actually look at this term 2/3 right before you square it. That 2/3 tells you what your parentheses is going to factor out into. So this will actually end up giving us, yeah, very good, Meredith. It will be x plus 2/3 in our parentheses. So of course, both our terms are positive here. So we will have a positive, and then that 2/3 is what this guy is going to factor into. And you know, you can do a quick check to make sure that works. If I multiply 2/3 with 2/3, I get 4/9. If I add 2/3 with 2/3, I'm going to get 4/3, which is our middle term. So you know this factoring works. So go ahead and factor your middle term by using this 2/3 over here. And it's actually the same thing you did in this example. Also, we had x squared minus 6x plus 9. And you will see we again use the same number 3 over here to factor our parentheses part. So that's always going to be true in these completing the square examples. Now, what are we going to get when we add negative 4/3 with positive 2? Because we need to clean out that terms outside of our parentheses. So what will this give us? Does that come out to be 2/3 as well, Clinton? Is that what you're saying? Okay, so basically remember here, you either use your calculator, or if you're trying to do this by hand, we need to have a common denominator. So multiply our 2 over 1 with 3 so that we can get that common denominator of 3, which will of course become 6/3, and then negative 4 plus 6 will give you 2. So this will become positive 2/3. And this is our equation in the transformation form. So we've got 3 parentheses x plus 2 quantity squared plus 2/3. Now graphing this is going to be interesting because you are moving 2/3 units to the left. Since that is x plus 2/3, that tells us the value of 2/3 is negative. So you are moving 2/3 units to the left, and the plus 2/3 at the end of our equation is telling us we are moving 2/3 units up. And then of course we have a stretch by 3 units. So this one, I would probably use my original equation to come up with some points. So let's see what kind of points we can get for this guy. So we are moving 2/3 to the left and 2/3 up. That's definitely going to be a point. So we'll just kind of have to estimate where that point is, but let's try and see what we get for some of these other numbers. So we'll do -3 to +3 and see what kind of values we can come up with. Okay, Deborah, I just saw your answer. Yeah, the 2/3 was correct. And then Clinton, you're talking about domain, but I'll come back to it. But yeah, let's look at what kind of values do we get so that we can graph this. So what does -3 give us? Okay, very good. -3 will give us 17, and -2. -2 is 6, -1. -1 will give us 1. Very good. 0, again, if you put 0 in for your x, the 3x squared and the 4x will become 0. So 0 will, of course, give us 2. Now, what will we get for +1? Very nice, Deborah. 9, positive 2. Lori, very good. So positive 2. Okay, 22. And then positive 3, I'm going to imagine is going to be again a larger number over there. So what do we get for positive 3? 41. Yeah, so unfortunately, those numbers will not be helpful for us, but we should be able to graph all of these here. So I've got the negative 2 and positive 6, negative 1, 1. Let's see, we've got 0, positive 2, and we've got 1, positive 9. Okay. And remember, our graph moved 2/3 units to the left. So approximately that's like, you can think of 0.666 repeating. So about zero point 0.7, which is really going to be, and this should be negative, sorry. We should be kind of able to estimate where that point is going to be. So, and that's actually going to be the lowest point on our graph. So you're going to look something like this. Let's put this on our Desmos and see what it ends up looking like. Okay, so we've got 3x squared plus 4x plus 2, and then our transformation was x plus 2/3 squared, and then of course we had plus 2/3 at the end of that. And again, you will notice, of course, the two graphs are overlapping again, but you can see if we try to zoom in, that lowest point on our graph is that negative 2/3 and positive 2/3, because that's by how our transformation was happening. And then of course our y-intercept is at 0, 2 over here. So this is what this graph ends up looking like. Like I said, you know, for us plotting this point, negative 2/3 and positive 2/3 is going to be a little bit of a estimate, but you would still get an idea. All right, so Clinton already told us the domain for this function, which was all real numbers. So that's going from negative infinity to positive infinity. Again, this is a parabola opening up. Now, what can you say about the range of this function? Yeah, very good, Clinton. Again, our graph is going upwards, which means it's headed towards positive infinity. And the lowest point on our graph, of course, corresponds to this point right over here. So you are starting out at positive 2/3 and you are going up to positive infinity. Alrighty, very good. So that's basically, again, you know, just make sure you are comfortable converting this from the standard form to the transformation form, because again, I believe you guys will be comfortable with the graphing. It's a transformation we want to make sure you're comfortable with. So they're saying any quadratic function is basically going to be a transformation of your basic f of x equals x squared function, which you can kind of think of the parent function for the quadratic functions. And so any kind of transformation you make, remember, is just creating a new member of that square family. So they're talking about, again, in section 2.3, we know we saw the function of f of x equals x squared. We know these functions are called parabolas, or these graphs are called parabolas. So we want to talk about some properties of parabolas. And right now we're focusing on the opening, the vertex, and the axis of symmetry. And we've kind of talked about a little bit of that. So the opening is basically talking about, is your graph going to open up or down? And that actually comes from this a value. So it can either be the a from the transformation function, or it can be the same a that you have here in the standard form. So this ax squared from the standard form and the a from the transformation form are going to be the exact same number. If you look at the two examples we have done so far, you will notice that this number 3, which is our a value, is the same number 3 over here in our transformation. For that matter, look at this first example. This number 2 is the same number 2 you had here. So it's always going to stay that first coefficient on your x squared term, which is going to be the a value. So if you have a positive a, your graph opens upward. If you have a negative a, your graph opens downward. Because remember, with the negative sign, you create a reflection. So that means instead of opening up, your graph would be opening down. So just if you have a positive a, graph opens up. If you have a negative a, graph opens down. And look at both these examples. We had a positive a for both of these, and both our functions, our graphs were opening up. So that's a good way to look at it. When we talk about the vertex, that actually comes from the highest or the lowest point of your parabola. And we kind of looked at that as we were going through these graphs. So look at these two function graphs that we have over here. You've got in the gray your basic f of x equals x squared function. Of course, you can see since this is a positive x squared, our graph is opening up. You will notice the vertex of our parabola is right here at the origin, 0, 0. And then when we make a transformation, which is this graph in red, that's where we've got a x minus 8 squared plus k. So we are moving so many units to the right and upwards. We don't know what those numbers are, but look how the vertex also moves. And the vertex comes from that horizontal and vertical movement. So the h and the k will actually tell you where the new vertex is going to be. And that's kind of what we were using here also. We knew our graph was moving 2/3 units to the left and 2/3 units up. So that basically formed the vertex of our parabola. We moved 2/3 unit to the left, we moved 2/3 unit up, and that became the vertex of this parabola. Same thing in example 1. Our graph moved 3 units to the right, and you moved 4 units up. So 3, 4 became the vertex of our parabola. And you know, when you're graphing parabolas, it's really nice to know where the vertex of your parabola is going to be, because you know that's going to be either the lowest or the highest point, and then you can start picking numbers on either side of that vertex so that you know what the left hand and the right hand side of your graph is going to end up looking like. So when you have a parabola opening downward, so this is going to be for the negative x squared function. That negative is what's making it open downward. But again, right now, the vertex is going to be at 0, 0. And since we are again moving by h and k units to the right and up, respectively, we again know the vertex of our parabola is going to move based on those h and k values. Now, you know, of course, you can be moving up or down, right and left. This graph is just giving us a general idea, but obviously you're not always moving to the right and not always moving up. But so those are the kind of things that they are talking about here. We know the h gives us the horizontal translation, so that's our left and right movement. The k will give us the vertical translation, so that will be the up and down movement. They're also talking about, since by default the x squared function will have the vertex at 0, 0, based on the values of h and k, we will know where the new vertex is going to be. If your parabola is opening up, then the vertex is going to be the lowest point on your graph. If your parabola is opening down, then the vertex is going to be the highest point on your graph. So something else to keep in mind, they're again talking about how to find the vertex by using those h and k values. The other thing that I wanted to mention is, what if your equation is given to us in the standard form, the ax squared plus bx plus c. In this case, when you have to find the vertex, you actually start by finding your x coordinate by using negative b over 2a. Once you find the x coordinate, put it back into the function, and then you can basically find your y coordinate. So it's actually going to be based on how the equation is given to you. If the equation is given to you in the transformation form, then you just need to use the h and the k coordinates to come up with the vertex of the parabola. But if your equation is given to you in the standard form, then use this equation to find the x coordinate for your vertex, which is negative b over 2a. Once you find the x, put it back into your function, and that will help you find the y coordinate. So two different methods of finding the vertex of the parabola. So that's what we have lined up here, are these two examples to help us come up with these vertex for each of the graphs. So this one is giving us the standard form. We are given f of x f of x equals 3x squared minus 12x plus 5. And to find the vertex of this parabola, we are going to use the equation x equals negative b over 2a. Now remember, this is your a value here, this is our b, and this is our c. So since they are asking us to do negative b over 2a, our b value is negative 12, a is positive 3. So just be careful, because now we have a negative sign coming from the b itself. We have a negative sign from the formula. So the two negatives will become positive. Of course, 2 times 3 will become 6, which will give you the value of 2. So we found the x. Now we need to find the y. So remember, for the y, you take this number 2 that we just came up with and put it back into the equation. So that's going to be 3 times x squared minus 12x plus 5, and then you're replacing your x values with the number 2. So what will this answer come out to be? Okay, Meredith, looks like you're having some trouble with your camera. Okay, sorry about that. You're getting -7. And Morgan and Grace, you guys got the same thing, okay? So that means now that we have our x and y values, put it together, and that will give you the vertex of your parabola. So 2 for the x value, -7 for the y value. Now, as you can see, our a value is a positive 3. So since a is a positive number, that tells us our parabola will be opening up. So if the parabola is opening up, that means the 2, -7, our vertex, is going to be the lowest point on your graph, okay? And all of these things really help us out when we are looking for what the graphs of these functions will look like. So like you saw, a is 3, which is a positive number. So that's telling us our parabola is opening up. And then our vertex of 2, -7 is going to be the lowest point on our graph. Okay. Now let's take a look at number 4 over here. Again, they are asking us to find the vertex of our parabola, but you can see this is given to us in the transformation form. So you just need to find out what your h and k values are going to be. So what do you think the vertex is? So what will be our h coordinate here and what will be our k coordinate here? Okay, Clinton, you've got -6 and -1/4. Okay, very good. So again, remember by default, and I'll just use, looks like we've got Alexandra joining us. Okay, so basically, guys, remember that your function, since it's given to you as x minus h, so if it's minus, then you know the number itself is positive, but here we've got x plus 6, so that means 6 itself is a negative number. So yeah, your h value is going to be -6. K always takes the same sign as what you see in the equation, so that will be -1/4. And let me see, I think Clinton, and then I saw somebody else's answer pop up. Meredith. Yeah, very good, guys. And again, since that 1/2 in the front, that's our a value, is a positive number, that again tells us that our graph is opening up, which means our vertex is again going to be the lowest point on our graph. Okay. Alrighty, very good. So before I move on to the other properties, did any of you have any questions at this point? Nothing so far? Okay. All right, so we've talked about the opening, we've talked about the vertex. Now let's talk about, we mentioned the axis of symmetry, but before that, we'll talk about the minimum and the maximum value, which again actually comes from the vertex of our parabola. So we know if our parabola is opening either up or down, then the domain is always going to be the set of real numbers or negative to positive infinity. The range will actually change based on how your graph is moving up or down. So the range of our quadratic function is actually going to be determined by that k value, or the second coordinate of our vertex. So if your parabola is opening up, which means a is a positive number, the range of our graph is going to be including k, going up to positive infinity, and we would say k is the minimum value of our function. And think about this. If your parabola is opening up, so let's do a rough sketch over here. If your parabola is opening up, then the vertex is going to be the lowest point, right? So if it's the lowest point, that means k is going to be the minimum value of our function. However, if our parabola was opening downwards, which means a was a negative value, then your vertex would be the highest point on our parabola, and that would make the k the maximum value of our function. So just depending on how the parabola is opening, you will know if your k is the minimum or the maximum value of the function. Additionally, when a parabola is opening up, they are saying our function is decreasing from negative infinity to h, which means it would be decreasing on this side. And they are saying it's increasing on h to positive infinity, which would be this side of our function. Now, this is if a parabola is opening up, but if your parabola is opening down, a is a negative number, the range of your function is going to change. It's going to now go from negative infinity to k, including k. Like I said, k will become the maximum value of your function. And now your function will be increasing on the interval negative infinity to h, so it's increasing here, and it will be decreasing on the interval h to infinity, which is going to be going down this way. So depending, again, opening up or down, that increasing and decreasing intervals are going to change. We had actually talked about this in the last chapter when I had introduced symmetry. Remember, we talked about symmetry with respect to the y-axis and symmetry with respect to the origin. But remember, parabolas have their own symmetry. Parabolas bring their own symmetry, and the basic function f of x equals x squared will always have symmetry with respect to the y-axis. And just look at this graph over here, you will see the y-axis is going right through that vertex of our parabola. And if you fold along the y-axis, the two halves of our parabola are going to coincide, right? So we have symmetry with respect to the y-axis, and that's for the basic function. But again, every parabola will have its own axis of symmetry, and that will be based on how your graph is moving to the right or left. So if your graph moves to the right, your axis of symmetry will also move to the right. If the parabola is moving left, of course, the axis moves to the left. So your axis of symmetry is always going to pass through the vertex. And since we know that we can calculate the vertex by using x equals negative b over 2a, that same equation gives you the vertical line, which is what we call as the axis of symmetry. So that same x equals negative b over 2a, which gives you the x coordinate for the vertex, is also going to give you the axis of symmetry. And that will, of course, be for our function in the standard form. If your function is in the transformation form, then whatever is your h value, that will give you your axis of symmetry equation coming from that. So I have a couple examples here just to make sure that you are going to be comfortable, identifying all these different characteristics. So this first example here is asking us to determine if the parabola opens up or down. What is the vertex, the axis of symmetry? They want us to find the range of the function. They also want us to find, do we have a maximum or a minimum value, and the intervals on which our function is increasing or decreasing. So let's start with the opening. Obviously, looking at the graph, what can you say about the opening? Does the graph open up or down? Yeah, like I said, that's easily identifiable. You can see the graph opens upward. Okay, what are the coordinates for the vertex of this parabola? And let me see if I can make this a little bit bigger so it's easy for you to see. So what's the vertex for this parabola? Yeah, very good. That's going to be the lowest point on our graph. So that's, of course, coming from -1, -9. Okay, let's see. They also asked us to find the axis of symmetry. So remember, your axis of symmetry always passes through the vertex, and it's definitely going to be a vertical line. So since this is a vertical line, remember vertical lines have equations of the form of x equals a. So our so the axis of symmetry, and remember again, the vertex can also help you come up with the axis of symmetry. It's always going to be that x coordinate. So write this as an equation. It's going to be x equals -1. Okay, let's see. So axis of symmetry always passes to the vertex. It's going to be the same x value. What can you say about the range of this function? Now remember, they've given us a blanket domain. As long as your parabola is opening up or down, the domain is always going to be all real numbers, negative to positive infinity. So what will be the range for this function? Meredith, very good. It will be going from -9 to infinity. Lori, you've got -1. Now remember, -1 is the x value, not the y value. And the range is always going to be the y value, right? So you have to start from -9. And since you're heading upwards, you're of course going towards positive infinity. And this one would of course be including -9 and going up to positive infinity. Okay, so can you tell me if we're going to have a maximum or a minimum value on this function? Minimum, okay, very good, because obviously parabola is opening up, so vertex is the lowest point on our graph. And what will be that minimum value? Very good, Lori. It is going to be -9. Remember, the minimum value is always the y coordinate of your vertex. So the minimum value is going to be -9. All right, let's see. And then the last part they were asking us to find were the intervals on which our function is increasing and decreasing on. So what interval is our function increasing on? And what interval is our function decreasing on? Okay, I've got 2, 0, -2, 0. Okay, you're going from -4, 0. Okay, remember, intervals are always in terms of x values. So for what x values would our function be increasing or decreasing on? And again, the vertex plays a crucial part, because at the vertex, it's going to change. So if you look at the graph over here, coming from the left-hand side, if I start at the very top of the graph here, and I start moving in this direction, you will see our y values are getting smaller, right? Which means on this interval, our function is decreasing, and it will stop decreasing once you reach the vertex. Then once we start at the vertex and start going in this direction, you will see, of course, our y values are now getting larger, which means our function is increasing. So you have to write in terms of the x values from which number to which number is our function decreasing, and then from which number to which number our function is increasing. And keep in mind, this is a parabola, which means it's going to keep growing as it goes up. So this will keep going upward. So what would those increasing and decreasing intervals look like? And again, remember, you can look at the little description they have in here in terms of the intervals where they will be increasing and decreasing on. Okay, Lori, you're saying decreasing -4, increasing -1. Again, you're just giving me single numbers. It's got to be an interval, like we write our domain and range in. So it's got to be those intervals.
Would it be increasing from -1 to infinity and decreasing from -infinity to -1?
Very good, Grace. Yeah, that's exactly what I was looking for. Very good. So yeah, let's talk about the increasing. That's starting at the vertex and going to the right. And since we know these arms keep growing, you are basically starting at -1, which is our x value, and you're going all the way to positive infinity. So we will be growing or increasing, I guess, from -1 to infinity. Although I believe your textbook actually likes to use brackets instead of parentheses, which is weird because normally for intervals we don't like to include them, but I think your textbook does. So that should be including -1 to infinity. And then on the left hand side is where our function is decreasing. So the idea is it's coming from -infinity and it's going to keep decreasing till it basically reaches -1. There we go. So it's going to come from -infinity and stop right when it gets to our vertex. So this should be -1. And again, they want you to include it. So put brackets on these numbers. Infinity, of course, does not take any brackets on it. So this was just an exercise to see if, if you're given the graph, you would be able to identify all of these different characteristics. But, of course, we should be able to do that just by looking at our equations also. So let's see how we can identify these same characteristics here based on these two equations. So let's start with number 6. Oh, let's see. Meredith, I just saw your answer. And looks like you've got -4 to 0 to -1 to -9. So yeah, it looks like you were again kind of just looking at the points. But as we just talked about it, you should be looking at the entire interval and not just the specific part to what's showing on your graph, okay? Oh, okay. All righty. Very good. All right, folks. So let's look at number 6 over here. Okay, so we are given, and you can see, of course, this is in the transformation form. Y equals 3 times x minus 5 squared minus 4. So let's talk about the opening first. What kind of opening does our graph have? Do you think it will be opening up or down? Yeah, because you have a +3 for your A value. So of course our graph is going to be opening upwards. Very good. Okay, so now let's talk about what is the vertex of our parabola here. Okay, Meredith, you've got +5, -4. Very good. Again, in the parentheses, we have x minus 5. So that tells us that the k value itself is a +5. And then, of course, we've got -4 for the k value. Very nice. What do you think will be the axis of symmetry for this function? And remember, it's an equation because it's a vertical line. So what will that equation be? Very nice, Grace. Yeah, it is going to be x equals 5. Remember, it's always going to be the x coordinate of your vertex. Alrighty. Of course, again, we know since this is a parabola opening upward, our domain is going to be all real numbers. What can you tell me about range? And if it helps, visualize your parabola. So this is our vertex at 5, -4. So what will be our range for this function? Very good, Meredith. Yeah, you will be starting at -4 and going to positive infinity since our graph is going upwards. And again, we would be including -4. Let's see, we've got opening, we've got the vertex, the axis, domain, and range. Now, will we have a maximum or a minimum value, and what will that number be? We have a minimum, okay, and at what number? Yeah, very good. Let's see. I've got Clinton, Meredith, Julia, very good, -4. Alrighty, and what are the intervals on which our function is increasing and decreasing on? And again, if it helps, you can kind of look at that graph to help you identify. So let's talk about increasing first. On what interval is our function increasing on? Okay, Meredith, you've got it's decreasing on -infinity to 5, and it's increasing on 5 to infinity. Do you guys agree with Meredith's answer? Grace, Lori, okay, very good. Yeah, so again, guys, you will see that this is where we are decreasing on. This is the portion we're increasing on. So you're basically coming, because this part of our graph would be, of course, going towards -infinity. This part would be going towards positive infinity. So in terms of the x intervals, yeah, you would be coming from -infinity to 5, decreasing, and then from 5 it would change, and then from 5 to infinity we would be increasing on. So let's do decreasing from -infinity to 5, and then increasing would be from 5 to infinity. So look at all of these answers that we came up with. You are essentially using either the x or the y coordinate from your vertex to come up with all of these characteristics. So the opening and the vertex help you come up with all of these other different characteristics. So I would like you guys to do the same thing we did for number 6, for number 7 over here. The only difference is this is given to you in the standard form. So to find the vertex, you would need to use the equation x equals -b over 2a. And then to find the y, put that answer back into the equation to find your y coordinate. So let me see what answers you come up with for number 7. Same characteristics that we looked at for number 6. Do you guys need more time or are you ready? Okay, Audrey, you said ready. Grace, you were ready. Okay, so what's our opening here, guys? Yeah, very good, because your A value is -2, right? This is our A value over here, and since it's -2, we know our graph would be opening downward. So that's our opening, very good. What's the vertex of our parabola? Were you able to get that? Three halves and 27 halves. I've got 3 halves and 15. Okay, so looks like you're getting 3 halves for the x coordinate. So that would be x equals -b over 2a. That's -b over 2a. So let's see, b is +6. A is -2, which is giving us -6 over -4. So the two negatives will become positive. And then 6 over 4, of course, reduces down to 3 halves. So we've definitely got 3 halves for our x coordinate, but looks like there's some different answers on the y coordinate. We've got 27 halves from Audrey. Grace has 15. What did the rest of you get for your vertex? Clinton, you've also got 27 halves. Okay, Grace, you're saying it's not 15. Okay, so, all right, let's see how we got that 27 halves over here. Okay, Meredith, same thing. Okay. So you're basically plugging in the 3 halves into your function. Now, when we square the the 3 halves, you would basically end up getting 9 over 4. Which again, we can go ahead and cancel out that 2 with the 4. So you would end up getting basically -9 halves when you reduce down that fraction. And then over here with the 6 multiplied by 3 halves, again, the 2 can go into itself once and go into 6 3 times. So you would end up getting 3 times 3, which is 9. And then, of course, we have the +9 at the end, which would end up becoming positive 18. So now you're adding negative 9/2 with positive 18. You can write that as 18 over 1. Find your common denominator. Again, if you're doing this by hand, or you can just plug it into your calculator, whatever you're comfortable with. And that will basically end up giving us negative 9/2. What will that be? 36 over 2. And that's where you get your 27/2 from. Yeah, so 27/2 is definitely the correct answer. Now that you have your vertex, we know our parabola is opening downwards. We'll see how that changes some of these characteristics. So again, just to give us a brief idea on the graph itself, we can do a rough sketch of our parabola opening downwards. Our vertex is at 3/2 and 27/2. So what can you tell me about the axis of symmetry in this case? Yeah, and again, remember guys, axis of symmetry is always the equation. Morgan, I just saw your vertex answer, very good. It's always an equation because it's a vertical line, so make sure you're writing it as x equals, and then again, your x coordinate for the vertex. This is a parabola opening downwards. So again, we know it's going to have a domain of negative infinity to positive infinity. But how does this affect our range with the parabola opening downward? What do you think the range of this function is going to be? So what did you guys come up with for the range for this guy? Okay, Meredith, you've got negative infinity to 27/2. Yeah, very good, because again, the range is going to be based on the y coordinate of your vertex. So you're going from negative infinity and you basically stop at 27/2 in this case, because our parabola is downwards. So it's going towards negative infinity. And of course, we would be including 27/2. Okay, now do we have, okay, Audrey, you agree with that, okay? Do we have a maximum or a minimum value? Maximum, very good. And what will that number be for the maximum? Yeah, very good. Again, the y coordinate. So we will have a maximum value, and that maximum value is going to be at 27/2. Alrighty. Now, what will our interval be on which the function is increasing and on which the function is decreasing? Okay, you've got Meredith decreasing from negative infinity to 3/2, increasing from 3/2 to infinity. Okay, let's think about this. So you're saying decreasing on negative infinity to 3/2. So you are actually talking about this part, but look at this. This one is actually going up because your y values are going to be getting larger. So you're increasing and decreasing will have to switch. And Audrey, you said you got the opposite. Yeah, because since your parabola is now opening downwards, the increasing and decreasing intervals will switch. So you will have increasing from negative infinity to 3/2. then again, they want you to include the 3 halves, and then that means we would be decreasing from 3 halves to positive infinity. So, you know, guys, what happens in this case is when you are looking at these characteristics, the opening with being downwards, a lot of these things are actually going to change. Now, vertex, axis of symmetry will stay the same. Domain will definitely stay the same. The range will change because instead of starting at 27 halves and going to positive infinity, you're now going towards negative infinity. So obviously our range is now from negative infinity to 27 halves. Instead of having a minimum value, we have a maximum value at 27 halves. And then like we just saw, your increasing and decreasing intervals will switch. So just kind of keep that in mind when you have a parabola opening upwards or downwards, how these characteristics change. Alrighty, did any of you have questions on this? No? Alrighty. So we've talked about all the different characteristics, and as I was telling you, all of these definitely come in handy when we are trying to graph these functions. Another points that can come in handy are going to be your intercepts. So we want to figure out where the x and y intercepts are going to be. And you know, we've done these calculations for other equations in chapter 1, but the process stays the same. If you're trying to find the y-intercept, all you have to do is let your equation, in your equation, let your x values be 0. So by letting your x values equal to 0, you can find the y-intercept, and of course switch that around to find the x-intercepts. We let our y value equal to 0. And so what happens is when you set the y equal to 0, you're basically solving a quadratic equation. So in this example over here, if I'm not mistaken, this is the same equation as number 6. So the 3 times x minus 5 squared minus 4. They're asking us to graph this. So we've already got the characteristics from number 6. We'll use that to our advantage, but let's go ahead and find out what the intercepts will be. And then let's talk about the graph of this function here. So to find the y-intercept, we need to make our x value 0. And then, of course, to find the x-intercept, we would make the y value 0. So let's start with the y-intercept. That would be a quicker calculation. We set our x equal to 0. So that would be y equals 3 times 0 minus 5 squared minus 4. And what do you think the y value will come out to be? Okay, I've got 71 from Meredith. So let's see. This guy would be 3. Of course, 0 minus 5 is negative 5. So that would be positive 25, right? Negative 5 squared. Then you are doing 3 times 25, which would, of course, give us 75. And then you're doing 75 minus 4, which gives you 71. So, of course, our ordered pair for the y-intercept will be 0, 71. Now to find the x-intercept, of course, you set your y equal to 0. So that means you're basically, like they said, solving your quadratic equation. So y equal to 0 would be 0 equals 3 times x minus 5 squared minus 4. So where would you start first to try and even solve this? Okay, Clinton, you also got 71 for the y-intercept. Very good. So what's the first thing we need to do? Because remember, our goal is to get x by itself.
Could you add 4 to both sides?
Very good, Grace. Yeah, that's exactly where you want to start. You want to start by adding 4 to both sides of our equation. So we can go ahead and get rid of that 4 here. Alrighty, very good. So we would have 4 equals, then of course 3 times x minus 5 squared. And then what would we do next? Yeah, very good. Divide by 3. Again, get rid of that 3 on the right-hand side. Now you're left with x minus 5, the whole quantity squared. And let's see, something was popping up here. Okay, so Audrey, you had divide by 3. We've done that. For the y-intercept, you got Meredith square root of 4/3 plus 5, the 5 outside of the square root. Okay, let's check that. So as you can see, we have the x minus 5 squared on the right-hand side. So again, to get rid of the square, of course, we need to use a square root. So we would need to take a square root on both sides. Now remember, guys, with the square root, you get one positive and one negative root. So the square and square root cancel out on the right-hand side, leaving us behind with just the x minus 5. Now you've got positive and negative square roots of 4/3. So before you move the 5, I actually want to talk about how we can clean up that square root of 4/3, because you know in algebra we do not leave radicals on our denominator value, so we would actually need to clean that up. So let's just look at how we can do that. So we have square root of 4/3. We can break that down into square root of 4 divided by square root of 3. Square root of 4 would of course clean up into 2, but square root of 3 would have to stay the same. And this is kind of what I'm talking about. We cannot leave a square root of 3 on the denominator. So this process is what we call as rationalize the denominator. I'm sure some of you have seen that in your previous classes. So to rationalize the denominator, we actually multiply both the numerator and denominator by square root of 3. And what this will end up giving us is 2 times square root of 3 on the top. But on the denominator, of course, when you multiply square root of 3 with square root of 3, that would end up becoming square root of 9, or basically just the number 3. So you can see we got rid of that radical on the denominator, and this is what we call as rationalizing the denominator, which means instead of a radical, it's now a rational number. So that's where that term comes from. So once you clean it up, we can rewrite this guy as plus or minus 2 square root of 3 over 3, and then you can go ahead and move that 5 to the other side. Sorry, that should be minus. So we have minus 5 here, and then you add that 5, move it to the other side. And so you can obviously see this is not going to be a happy number. This is probably a decimal approximation. So we've got plus or minus 2 square root of 3 over 3, and you're adding 5 to it to get your x intercepts. So if you had to write these guys as ordered pairs, that would be positive 2 square root of 3 over 3 plus 5. Remember, our y value was 0, so that would be comma 0. Your second ordered pair would be negative 2 square root of 3 over 3 plus 5, and again, comma 0. These would be your x-intercepts. And then, of course, we've got our y-intercept over here. So as you can see, these numbers will just give us an approximation of where the x-intercepts are going to be, but they probably will not be very helpful in our graph. But can you tell me what the decimal approximations for these numbers are? So if you did 2 times square root of 3, I guess we would divide that by 3 and then add the 5. What kind of approximations are we looking at? Okay, Clinton, you've got 1.154. Okay, 1.154700053. Okay, so about the same answer as Clinton. And for the other one, because there should be one with the positive 2 square root of 3 over 3 and one with the negative 2 square root of 3 over 3. Okay, Clinton, you've got negative 1.1547. Okay, so which answer is for which of the two x-intercepts? Because when you do positive 2 square root of 3 over 3 plus 5, it's going to be none of these answers that I'm seeing so far on the chat. Clinton, I got a different answer. Let me check my math again. Taking 2 times square root of 3, dividing it by 3, adding the 5. Yeah, I got positive 6, 0.14154 something. So for this guy over here, I am getting approximately 6.15. And of course, the numbers keep going. I'm just rounding it to 2 decimal places. What are we getting for the negative? I think, Grace, I saw you give us negative of that number. Okay, so if we did negative 2 square root of 3, yeah, I'm not getting negative 6.15. Meredith, you gave me 3.85, and that's what I'm coming up with. Yeah. So for the negative x-intercept, it's going to be approximately, and again, just rounding it to 2 decimal places, 3.845. So that will round down to 3.85. Okay, Morgan, you're changing to 3.85. Okay, very good. So yeah, even though you have the negative 2 square root of 3, because of that plus 5, you actually still end up staying with the positive. So both our x-intercepts are actually going to be on the positive side. But like I said, you know, these will be numbers that give us an approximate idea of where the x-intercepts are going to be. But, you know, we do have some other points. Now you've got 0.71 here for the y-intercept. So trying to graph this is going to be pretty interesting. And remember, you can still use all the properties we looked at here in number 6 because it's the same function. We know this is a parabola opening upwards. We know the vertex is at 5, -4. So you can actually start at that point to graph this function. So that means we're going out 5 units to the right, 4 units down. So this is where the vertex of our parabola is going to be. We know at 6.15, so just a little bit after 6, is going to be one of our x-intercepts. At 3.85, which means just a little bit before 4, you are going to be at your other x-intercept, right? So those would be the two places where our graph would be crossing the x-axis at. And now, since your y-intercept is at 0.71, that will be kind of hard to graph on our little 10 by 10 grid over here. So we'll just do a general shape of our function here. something like this for our function over here, but I want to show you on our little Desmos calculator what this guy ends up looking like. So we've got 3 parentheses x minus 5 squared, and then we had minus 4. So as you can see, oops, right over here, just a little bit after number 6, we've got our x-intercept, so they've got 6.11155, which is approximately to what we had. This one here is at 3.845, which is of course what we got as our 2 x-intercepts. And then we should be able to see here on the y-axis that our y-intercept is at 0.71. So you can kind of see what that entire graph would look like if we zoom out. Okay, so we can kind of do a general idea of what this graph would look like on our piece of paper, but you know, obviously we're going to be restricted by our graphs over here. So any questions on finding the x and the y intercept over here? Okay, let's try and do that same thing for number 9. Let me see what kind of x and y intercepts you guys come up with. Meredith, I believe so. Yeah, it looks like because you've got x squared plus 6x plus 9, which is a perfect square trinomial. So yeah, we would be able to factor this out into just one number basically. And looks like your k would be 0. Yeah, which is okay. I mean, that happens. Do you guys have your x and y intercepts? What did you get for your x-intercept?
-3.
-3, okay. And the y-intercept?
9.
9, alrighty. So let me just show you that really quickly over here. So obviously to find the y-intercept, you just make your x value 0. So that would mean we have 0 squared plus 6 times 0 plus 9. Of course, all of these numbers would just end up becoming zeros. So you would basically just left with y equals 9, which would give us the ordered pair 0, 9. For the x-intercept, we would make the y value 0, which would end up just giving us 0 equals x squared plus 6x plus 9. And you can either use factoring, or you can use the quadratic formula to simplify this, whatever you're comfortable with. Factoring actually will be pretty straightforward, because this factors into x plus 3 and x plus 3, because it is a perfect square trinomial. You can also write it as x plus 3 to the second power. But basically, if you take the x plus 3 and set it equal to 0, you would end up getting x equals -3. So you actually only have one x-intercept, which would be at -3, 0. You could also rewrite this function as x plus 3 squared.
Hey, stop it. Stop.
As Meredith was mentioning, that actually means you don't have a k value, because technically
Totally.
your k value would be 0, right? So you can also use this h and k to help you out. So if we rewrite it in this form, can you tell me what the vertex of our parabola is going to be? -3, 0, right, Meredith? Because that's a x plus 3. So that means your h value itself is actually -3. And since we don't have the k, that makes your k is going to be 0. So your x-intercept also happens to be the vertex of your parabola. So, if we try to graph this function, you would have -3, 0 as your x-intercept, but that's also the vertex. So what that actually means is that your parabola is going to be sitting on top of your x-axis, and then at 0, 9, we would be crossing the y-axis at. So this is the vertex on the x-axis. We've got our y-intercept. Now, what else can you do to complete this graph? What you have right now is basically the right hand side of our graph, because we can do, since we're going from our vertex, the right hand side. So what can we do to get the left hand side graph? So you've done enough graphing at this point that I would kind of think you have some idea that you could use to help you out here. So what are you thinking? Okay, Meredith, you're talking about expanding the graph. Not sure what you mean by that. Grace, you're talking about just picked another x value and plugged it in. Okay, you're talking about since it keeps increasing. Okay, but I'm talking about like, how do we get this part of our graph here? So Grace, you were talking about just picking another value for x. You can do that, or remember, you can always use symmetry. We know parabolas have symmetry. So if from my vertex I am going 3 units to the right, where I have this point 0, 9, you can actually go 3 units to the left from your vertex. So that would be going 1, 2, 3, and you would again actually be crossing at 9 because of that symmetry. If it helps, kind of imagine an axis of symmetry passing through your vertex. So this distance here is 3 units, which means you should have a distance of 3 units going the other direction also. And so then you can kind of, and that's a really bad graph, but you can kind of get an idea. of what your graph would look like. So this ordered pair here would then end up becoming -6, +9. We've got 0, 6, 0 and +9. Then of course our vertex was at -3, 0. Or the other thing you could have done is just create a table. And we know -3, 0 is our vertex. So go on either side. So you could have used -1, -2, 0 on the right-hand side, and then you could have used -4, -5, -6 on the left-hand side and get enough points so that you know what the graph of your function will end up looking like. And then, of course, you can use the different characteristics that we looked at with what's the opening, where is it increasing and decreasing on, does it have a maximum, minimum value, and all of those things can help you out also. So questions on number 9? Okay. As I was telling you guys earlier, you can definitely use the idea of symmetry, which is what I was showing you right now. So since the x-intercepts, they're saying are opposite sides of the graph, they are going to be equidistant from the axis of symmetry, but this is true for all points that are going to be on either side of your graph. Also, to solve the x-intercepts, you can always use the quadratic formula. Now, we can also use the graphs to help us solve quadratic inequalities, which is kind of what we looked at in the previous chapter. So they are saying for quadratic inequalities, you can solve the quadratic inequality, which would be basically of this form, ax squared plus bx plus c. And of course, you know that inequality symbol can be any one of the 4, greater than, less than, greater than, equal to, less than, equal to. But you can basically use the graph of your function to help you solve the quadratic inequality. So just graph this function, and then where the y values are going to be positive, negative, or 0 at. Morgan, were you saying something? No? Okay. They are also saying the values of x that would satisfy the inequality are the same value of x for which your y would be greater than 0 on the function itself. So again, basically, like I said, the graph helps us visualize where the y values are positive or negative or equal to 0 at. So just your steps involved in simplifying this. Make sure you have 0 on one side of your inequality and all of your terms are on the other side. So get 0 on one side and your quadratic polynomial on the other side. When they are saying about finding all the roots, they're basically saying find all the x-intercepts. So your x-intercepts are going to be your roots or solution for your quadratic equation. Graph your corresponding quadratic function. So make sure you go ahead and graph that. And then your roots, like I said, determine your x-intercepts. And then basically you have to read the graph. So let's go ahead. I think we have enough time to look at this inequality over here. So if you had to rewrite this by getting 0 on one side and moving everything else to the other side, what would this inequality end up looking like? Okay, Morgan and Meredith, you guys were actually talking about the inverse and the opposite for that graph before. Yeah, I just saw that. Are you guys okay with how we came up with the graph on those functions? Yeah? Okay. All right, so rewriting this inequality, guys, what will it look like?
Would it be x squared minus 2x minus 8 is greater than 0?
Very nice. Yeah, exactly. So all you would do is just go ahead and subtract that 8 to the other side. These guys would cancel out, and you get x squared minus 2x minus 8 greater than 0. And now this one, you can set it up as your quadratic equation and then graph that. So how would you go about graphing this? What do you want to use? Do you want to do a table? Do you want to use the vertex? Probably the best thing would be to definitely find the vertex so you know where the lowest point on your graph is going to be. So can you tell me what the vertex of this parabola comes out to be? Again, your vertex would be x equals negative b over 2a. And looks like Grace, you came up with positive 1, negative 9, which would be negative of negative 2, 2 times 1. So that's positive 2 over 2, which gives you the x value of 1. Y value would basically be 1 squared minus 2 times 1 minus 8, which would be 1 minus 2 minus 8, which gives us negative 9. Alrighty, very good. Positive 1, negative 9, and then looks like Meredith, Audrey, you guys got the same result. Alrighty, now that we have our vertex at positive 1, negative 9, which will actually be a point down here, let's go ahead and find some other points. Maybe let's try and see where our x and y intercepts are. So let's look for y-intercept by making our x value 0, and what will that give us? Lori, you got 1, negative 9 for your vertex. Very good. Meredith, yeah. Our y-intercept will come out to be negative 8. So that's the ordered pair 0, negative 8. Now let's talk about the x-intercepts by making our y value 0. So 0, negative 8 will be a point right here. So again, guys, I'm actually going to use the symmetry to help us out. Now remember, this is our vertex, which means our axis of symmetry is passing through this point. So if I have this 0, negative 8, which means I will also have positive 2, negative 8 as my point over here. So using symmetry, we can get those 2 points. And then what do we get for our x-intercepts? Let's see, Audrey, you've got positive 4, 0, and negative 2. 0, okay, very good. So that means you have 0 equals x squared minus 2x minus 8, where we set our y equal to 0. And then, of course, you can actually factor this quadratic equation here. So this will factor into x, let's see, plus 4, x minus 2, because positive 4 and negative 2, when we multiply, we get negative 8, but that won't give me negative 2, will it? So that means we actually need to make our 4 into a negative number. and 2 into a positive. And when we add them, we will get -2. So yeah, it needs to be x minus 4 and x plus 2. Set each one of them equal to 0, and you'll get x equals -2, x equals +4. So your ordered pair should be +4, 0, -2, 0. And looks like Audrey, Meredith, you guys have those. Alrighty, very good. So +4 and -2. And again, you should see they are the same distance from your axis of symmetry. So using this, we now have the graph of our function over here. Now, they are asking us, where is this function x squared minus 2x minus 8 going to be greater than 0? So do you have an idea of what that interval notation will look like? Where is this function going to be greater than 0 at? Because remember, if you look at the graph, right at the x-axis, our y values are 0. Below the x-axis, the y values are negative. Above the x-axis, the y values are positive. And they are definitely asking us, where is this function going to be greater than 0 at, right? It's going to be greater than, or the y value is positive. So what intervals would those look like? At 4, 0? Again, Lori, you're giving me a point. It's got to be an interval. Grace, you've got -infinity to -2 union 4 to infinity. Very good, very nice. Yeah, because this part of our graph is where your y values are greater than 0. And this is again where the y value is greater than 0. So this is going from, and this is going to be how you write your solution set the way Grace has it. We're going from -infinity to -2. You're not including -2 because this is just a greater than. There is no equal to in there. So going from -infinity to -2, and then we pick right back up at +4. And now you're going to +infinity. So it's going to be just those two little arms of our graph that are above the x-axis where your solution set is going to be. Okay, number 11 is actually using the same function. They just changed the inequality symbol on us. So we'll talk about that tomorrow. So just look through this. Let me know if you have any questions, and then we'll answer any questions that you will have tomorrow. Okay, guys? All right, everybody, be careful, be safe, and I will see you tomorrow. Have a great day, guys. Be careful. Bye-bye. Morgan, just class on Wednesday.
No, duh. I knew that. Oh, geez. It's been a
Yeah,
long
I
day.
know today's only Tuesday.
So sorry.
One more class. No, you're fine. Not a problem. All right, I'll see you tomorrow.
I'm like up all night with little puppies. So
I am so sorry.
have a good one. Thank you.
You as well. Take care. Bye, guys.